Hello, everyone. Thanks for joining us for our next live session. I'll be your producer for our session, but before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel. With that, I'll turn it over to our speaker for today. Thanks for joining us.
Perfect. Hi, everyone. I'm Scott Holden. I'm based out of Melbourne, Australia, and I'm a software solution engineer team lead. So looking at everything agentic DevOps, the world of agents, and funnily enough, agents building agents. So really excited to be here today to run through agent to agent at scale and look at the Microsoft Agent Framework from a little bit of a different view, taking you from first fundamentals through to full agent to agent systems and everything in between. It's a very full, very jam-packed session for today, so we'll dive straight in. But if you do have questions, please feel free to place them throughout, and we'll spend some time again for Q&A as well. So let's probably start off with what is an agent, because this is the core topic and the reason why we're looking at different frameworks and different approaches to deliver agentic behavior. At the end of the day, an agent is so much more than an LLM call. It is really that interaction loop, taking action, making decisions. And when it comes down to it, an agent could be as simple as a for loop, sitting there processing until the LLM's done, but can be as complex as multiple integrated systems working together with tool calls that might run for days and days on end rather than instantaneous. I will call out here that when we begin to look at agents, though, we can break it down into three very simple categories: inputs, outputs, and tool calls. Basically, what do we need to provide into an agent at the beginning or provide to an agent during a conversation? What outputs do we expect from the agent itself, either mid-conversation or as part of a terminating event? And then what do we expect the agent to be doing internally? It's really interesting because when we begin to look at patterns like RAG and those more traditional approaches to LLM, we've really thought of tool calling, or rather context providing, being something we do up front. When we look at an agent, we may actually provide very little context up front besides a system prompt and the user's input. The actual retrieval and context discovery can be done as part of the LLM's journey through that information. It's important to call out here that each of these components, retrievals, actions, memories, you can code from scratch. And we'll talk through the different approaches and where you might choose to actually build things from scratch as we go. But the biggest thing to keep in mind here, that if we break it down into inputs, outputs, and tool calls, actually assembling an agent becomes relatively straightforward. Well, at least in theory. One of the biggest things we've found is with a number of different protocols for inputs and outputs, LLMs providing different types of APIs to actually be called, and tool calls ranging from being code to APIs to being MCP or similar. It really is a little bit of a wild, wild west. So while the topology of an agent itself is relatively straightforward, actual implementation can be a little bit tricky. The other important thing to note here is that when we look at that input and output, previously it was a user interacting with an agent, but we are beginning to see the rise of agent to agent and agent coordination or orchestration. And it's really interesting to see what we can do when we begin to build multiple agents and allow them to interact with each other. We'll have a look at a few examples of that a little bit later on today in terms of how we begin to compose agents together. But we can begin to think of it now not just as a user message being an input, but also an agent message, another agent calling into our agent to invoke it, and then receiving messages back from that agent in turn. Beyond the scope of today, but I feel it's really important to call out, is the rise of event-driven agentic behavior. So rather than necessarily being triggered off a comment or a piece of text, rather being driven by an event, something that happens within an environment. I like to think of this as the email or the monitoring scenario, where it's not necessarily direct user input that triggers an agent, but rather an event that occurs within an environment. The really interesting thing here is when we begin to combine that world of event-driven with the ability to act, you can build incredibly powerful systems. But we need to keep in mind that if we're giving an agent the ability to take action in response to something that's happening, we can't forget about things like security and identity and making sure that we're not just protecting the AI components of our agent, but the application and the programmatic components as well. We'll talk about that as we go through. But I want to pause there for a second and just kind of revisit why we're looking at this. Well, to a degree, it's because we have a couple of ways we can approach an agent now. We can build an agent through entirely low-code platforms like Copilot Studio, for example. But we can also choose to code these from scratch. And when I say from scratch, you can go the whole way down to running Foundry Local on your machine with a local LLM running entirely on your laptop if you'd like to. But I always find it's important to consider, well, why would we actually want to write it as code in the first place? And this is a really interesting conversation because I believe that there are a lot of agents, a lot of copilots that are better off the shelf. It doesn't necessarily make sense to write a complete custom agent from scratch from code if it's for a very generic approach or pattern or something that is available off the shelf in something like GitHub Copilot or Copilot for Microsoft 365. But when it comes to control and customization, this is where building agents as code really comes forward. This is where I really challenge people in terms of when they begin to think about writing agents as code, begin to realize the power that it gives you in terms of being able to customize and control everything. When we look at some of the low-level tool calls and agent discovery, you can really build whatever you want. It is an open ecosystem, but you're also required to manage that longer term. So if there is business differentiation, if there is a reason to be building this to take that low-level customization and control, building agents in code can be incredibly powerful. The other key thing here is that when we're building agents in code, we can actually begin to use agents to build agents. And we'll touch on this in a demo at the very, very end. But we can use off-the-shelf agents like GitHub Copilot to assist in building. This gives you the ability to have the best of both worlds, being able to have more of a specification or user requirement driven approach without necessarily having to write everything from scratch. The second piece when it comes to local experimentation is something that I find quite interesting. And I often find that this is a really good indicator of if writing an agent as code is right for you. When it comes to writing an agent as code, the majority of use cases that really, really benefit from it need local debuggability, the ability to step in and step through and understand what's happening at a tool call level, or how an agent is formatting a response, or how a system is passing information backwards and forwards as part of an MCP or any other tool. This level of introspection is something you really only get from a code-first experience and goes hand in hand with customization. I find that if we're building very simple approaches, then we may not necessarily need local experimentation if we've just got a prompt and that's it. But when it comes to running local MCPs or running MCPs that may require dependencies that may not be available on a low-code platform, that local experimentation is incredibly powerful. The only thing I'll note here, and this is kind of the double-edged sword of each of these, if we've got local experimentation, you need to have a deployment strategy. You need to be thinking about how we actually deploy an agent and run it in a reliable and scalable manner. We'll touch on this a little bit later when we look at Dev UI and some of the deployment options that we have for these agents. But it's important to note that it's not just good enough to be able to run this locally on your machine. We need to be thinking about how we then deploy and productionize. But the biggest reason that I see people reach for code when building these agents, and it kind of comes back to what we did before all these frameworks was available, was portability. The ability for you to customize and control every single piece of the equation, right down to how these are hosted. One of the nice things about the Microsoft Agent framework that we'll look at in a moment is that it's open source and extensible. It's not a fixed product set, but rather a library that you can build on top of. This means that you might be running the agent framework in a restricted environment or in an on-premise environment or in something like Azure Local, but calling out to a large language model maybe sitting on the cloud or sitting on some compute in a data center. That level of portability is something you only get from a library-based approach. But it also means that because we're building on top of a library, we need to have coding standards. We need to be considerate of how we structure our agents, how we document them, and keep in mind that, hey, we might be able to just pick up and use any model we want, but are we really getting the best we possibly can from a given model? It's always one of those big considerations. But by this point, if you're like, yes, I need to be able to customize and do something that low-code agents can't do today. I need to be able to run it on my computer, understand and go deep into the code of what this agent is doing. And I need to be able to run it on environments that may exist in on-premise data centers or may map to your existing cloud strategy. The Microsoft Agent Framework is actually a really good approach. Now, why is this an issue though? I mean, like, hey, we've had frameworks for ages. If we look back in terms of like LangChain and semantic kernel and AutoGen and all of these different frameworks that kind of had their own little benefits, but also some downsides, you ended up with this fragmented framework ecosystem where you're not really leveraging a framework by itself, but rather you're leveraging 30-40% of a framework and building the rest yourself. And it really comes down to maturity. A lot of the frameworks were focused on solving a particular problem set rather than abstracting to a higher level in terms of giving you those concepts to be able to orchestrate yourself. So fragmented frameworks meant that we were stuck deciding between things like AutoGen and semantic kernel. We need multi-agent. Which tool do we pick from? The Microsoft Agent Framework, as we'll talk about in a moment, combines these together and gives a simpler approach. The other thing to keep in mind, and this is something that really personally frustrated me with a lot of the frameworks that were out there, is that running on your local machine is fine, but then getting to production is incredibly complex. Things like state management being purely in memory doesn't work at scale. Things like how do we host and expose these services in a way that actually provides authentication and authorization were something you had to build yourself. So if we look at the frameworks of a past and really what's happened so far, you ended up with these frameworks that were great for a proof of concept, but not really enterprise ready. And so if you haven't played around with it already, I highly recommend having a look at the Microsoft Agent Framework, which is what we'll be focusing on today and diving into some code in a few minutes. But it really takes it to the next level in terms of providing a library and a framework that's still extensible, that's still locally executable, but also gives you that simple path to production. And when we begin to look at that shift across, the path to production isn't, funnily enough, just about throwing it in a container or stapling on some cloud services. There are fundamental components that a framework needs to actually be production ready. And one of the biggest ones we're seeing, that top line there, is modern protocol support. It's all well and good to have a framework that can call a large language model and have its own proprietary way of integrating with tools or systems, or rather just giving you a base class that you have to implement yourself. What we're really seeing is modern frameworks now begin to use standardized protocols like MCP, like A2A, to actually provide composability. And it's not just composability within an individual agent, but within an entire system. Now, this level of composability is something that I really love in terms of being efficient with the code that we write. Having to write, and I'll take you through the journey of back when we had first generations of tool calling, or even before we had tool calling, when we were trying to do structured outputs to emulate tool calling, you had to write everything yourself. How you specify schema, the parsing, the validation, how we then take a JSON payload and then convert it across into a method call. All of these really low-level fundamental pieces, you found yourself writing yourself without actually giving you any benefit. There wasn't really any need to write that, as it's pretty common across the board. And what I've seen, especially around things like MCP and skills, is the whole idea of us being able to take a step back and look at what is the functionality required at a specification level, and using that to actually expose our tools and integrations. Now, I could talk about MCPs for all day long, and we'll come back to that in a little bit when we look at some of the actual implementations. But I also wanted to talk about the very bottom one, observability, because this is the other piece that I find, funnily enough, a lot of the frameworks started to get there, but really stopped too early. When we begin to look at observability, it's a lot more than just seeing a bit of output in a console. Actually being able to visualize workflows and complex agent interactions really helps you understand how these agent-to-agent systems work. And when I begin to look at agent systems that I've helped develop and that I've brought into production, not just understanding what's happening call by call, but actually understanding the state of each agent, how it's recovering if it failed to make a tool call, or actually understanding your dependencies is incredibly important. The other thing there is long-running execution, because this is the one thing that everyone forgets about, but is core to the modern agentic world, is that we're no longer talking about milliseconds or seconds. We're talking about days, months, years, potentially. Agent invocations aren't just something that's a single chat conversation. It might be waiting for an approval, or waiting for an event to happen, or passing out to another system that might be down right now and may come back later with a response. We need to be designing our agentic systems in the same way we built monoliths and microservices or distributed services, as actually being resilient when it comes to dependencies. And protocols like A2A begin to actually give us that sort of approach. Now, I mentioned MCP a couple of times. We're not going to go super deep into the low-level intricacies of MCP, but I think there's some very, very important notes to have here. Model MCP, or Model Context Protocol, gives us a way to plug in different tools. For those that have used MCP, you probably know a lot of this, but I think it's important to differentiate what we mean when we talk about clients and servers and, well, to a degree, hosts. Clients are tools that use MCPs. This could be GitHub Copilot, it could be Visual Studio Code, it could be maybe a custom application. Servers are the actual tools themselves, where they run, how they, or the actual implementation of the MCP tools themselves. It could be something off the shelf like Playwright or Microsoft's MS Learn MCP server, or it could be a custom open source MCP server. I really suggest that if you haven't dug much into MCP, have a little bit of a look at how MCP can simplify the way you do tool calling. But it's all well and good to have these clients and servers, but we actually need to think about where these run, especially when it comes to MCP servers. We're seeing this pivot across to remote MCP servers, but at the same time, we need to be thinking about, hey, if I need to run something locally, how do I sandbox it? How do I create a security boundary around what's actually being executed? We've got some really cool approaches here that we can talk about a little bit later on. But for the moment, just be aware that when we look at MCP, we have the clients and the servers and the environment that it sits within. The other acronym that I used, and I promise we'll get into code in a second, but I think it's really important to talk about these acronyms first, is A2A, or agent to agent. And you might be thinking, A2A, what does this mean? Like, surely we can just have an agent make a tool call and then pass that across to another agent. Well, when we begin to plug agents that may not be written by the same organization, or maybe written by disparate teams, or may even exist across off-the-shelf versus custom-coded solutions, we need a common protocol to actually integrate between. And A2A gives us the ability to expose what an agent can provide to another agent, allow that agent to then consume it, and interact between those two agents. My favorite part about this is there are specifications for streaming, for long-lived executions, which is what we really need in a modern agentic world. But more importantly, because Microsoft Agent Framework in particular has A2A available as both client and server, without writing more than a couple of lines of code, you can actually wrap your agents in A2A and also consume external A2A agents very easily, in the same way you'd define a normal agent. So with that, I actually want to dive in and let's do some demos. Let's look at a lot of this hands-on. And as I said, I want to take you from those fundamental basics of what it means to use the Microsoft Agent Framework through to building truly agentic systems and building agent-to-agent interactions locally and remotely. So with that, let's jump across into VS Code and look at our first demo. For today, we'll be using Python, but everything we see here can also be done within .NET if you prefer. Plus, we have some additional ports coming. One really interesting thing here is that if you've used AutoGen or Semantic Kernel or any of the other third-party frameworks before, Agent Framework feels a lot simpler, but actually gives a lot more extensibility. And my best example of this is when we begin to look at things like, hey, the different agents that we want to create via an agent client, we have the option to use either off-the-shelf clients like the Azure AI Agent Client, which we'll talk about in a second, but also third-party or custom agent clients. You can even implement your own if you'd like to, giving you the ability for full extensibility. But let's kind of run through what a flow looks like to actually create an agent and let it run, and talk about the differences between this versus just using an LLM from scratch. The first thing to note here is we use an agent client. This is kind of our structure for actually spinning up the backing resources that might be required. This is where we might have a connection to a large language model. This is where we may call across and create something in AI Foundry as an agent, for example. And in fact, the Azure AI Agent Client gives us the ability to orchestrate agents in AI Foundry, but from our applications. This means that we can integrate with existing agents that may be pre-created in AI Foundry, or actually define our own agents as code that will run on top of AI Foundry agent service. This is really neat because it means you can have consistency in the way that you define an agent if you're using AI Foundry. The second thing to note here is that the way the Microsoft Agent Framework has been designed is that it's not just a set of clients and you pass in some API keys and kind of just put your hands in the air. It's been designed in a security first mindset. So you'll notice here, I'm actually using my Azure CLI credential to authenticate. This means, and like it's probably going to shock a couple of people that are on the call, I can jump into my environment.env file and leak it on screen because there's no passwords in here. There's no API keys in here. Rather than using API keys, we're actually using identity to authenticate. This means when it runs on my computer, it uses my identity. If I pass this along to a coworker and it runs on their computer, it uses their identity. But more importantly, when I push to production, it can use the production system's identity. Here, I'm just using the Azure CLI credential to make things a little bit faster, but we do have the default Azure credential, which works across multiple environments and different services like Azure App Service and AKS. But with our Azure AI Agent Client, we can then go ahead and build an agent. And you'll note here that all of the methods we're using inside of the Microsoft Agent Framework are fairly straightforward. They do have a lot of extensibility in terms of options you can configure, but it's designed to focus on what are the core requirements for building an agent. So here, we're just going to build up, and let me turn on word wrap for a second so we can see the prompt here. We're going to build up a very simple agent, which is focused on being a venue specialist, picking a venue for an event. And you can see here, I give it instructions, which is the system prompt, and I can give the agent a name, which is great for both observability, understanding what this agent is and what it's doing, but also when we begin to compose these agents, we can refer to them by name. The key thing here to note is that creating the agent versus running the agent are actually two separate steps. This means your application can spin up, start up, create an agent, have it ready to go, and then just run the agent when a request comes in, rather than having to recreate agents all the time. The other key thing here is that we have this level of separation. We have at the top here the agent client that we're using, but create agent is actually just a generic method. I could switch this across to a completely different agent platform, or one that runs locally in memory, or the responses API for OpenAI. This gives you the ability to switch out clients without necessarily having to change your agent creation. The only thing that I'll point out, which is really important, is if you're switching between models or different agent platforms, just double check the functionality that's there. Things like tool calling may not be available on some models, so it's important to understand what is and what isn't supported. The last thing at the bottom here is we can do our agent run and actually kick off this agent execution. So my favorite thing here is that in basically 14 to 15 lines, we've set up how we want to create this agent, how we want to authenticate, and the resources we want to talk to, in this case, AI Foundry. We've created the agent as a resource, giving it our instructions and now having the ability to use this agent, and then finally executed the agent and got back a result. And we can actually kick this off to have it run in the background and give it a couple of seconds while we continue on. The other thing I'll note here is that when we begin to look at all of this, it does all sit within the agent framework. You'll notice here I've got agent framework.azure, agent framework.observability. There are a lot of different packages inside of agent framework that allow you to pick and choose the pieces you'd like to use. If you prefer to talk directly to OpenAI's models rather than going through AI Foundry, there are packages that allow you to do that. Vice versa, if you just want to talk directly to an LLM rather than building up an agent, there are chat clients built into Agent Framework. I kind of think of Agent Framework as the tool I reach for by default, rather than including a large language model's client directly. And we can see here in the background, it's kicked off, it's authenticated as me, and generated some fantastic ideas for a venue. But there's a little bit of a problem. Here, it's generated ideas for venues, but it's only used its internal knowledge. It's only used the knowledge of the LLM. What happens if these venues have shut down? What happens if they're not open on the date in particular? What happens if they've changed their venue hire size and can't actually fit everyone in? What we've built here is a great agent in isolation, but it's isolated from the outside world. So I actually want to jump across and begin to talk about how we can augment our agents using off-the-shelf tools. And when I say off-the-shelf tools, I mean these are tools that we don't have to write ourselves or hunt down, but things that are actually baked into the agent framework directly. In particular, things like web search, giving us the ability to actually reach out, search the web, find relevant results, and bring it back as part of an agent's execution. So let's jump across and see what it takes to actually go from creating an agent to actually then invoking a web search as part of the agent's run. So the first tool we'd like to give it. You'll note that everything looks roughly the same here. I'm creating a client, I'm creating an agent, but you notice here I'm giving it a set of tools. We can provide multiple tools, one or many. The first agent didn't have any tools. This agent has the hosted web search tool. This means that this agent can actually reach out and perform a search. In this case, it will use Bing to find relevant information and retrieve that information back into the conversation. You'll notice that our agent.run looks exactly the same. We haven't had to introduce a for loop or custom tool calling or anything that has to deal with the output of these tools. It's all actually part of the Microsoft Agent Framework itself. In saying that, if you wanted complete control over the tool's execution and the life cycle, we'll look at that a little bit later on, but there is full extensibility there. My favorite piece here is that just as the hosted web search tool is out of the box, you can actually build your own tools that can be used in exactly the same way that are reusable both across your organization or within a project. I've found that common things like being able to look up reference information on a knowledge base is really great to use across multiple agents. You might choose to scope what they can look at so they don't have access to everything, but having the ability to reuse tools without writing from scratch every single time makes life so much easier. Now, I want to show something really interesting with this execution though. And let's go ahead and we'll clear this up and we'll rerun our agent. Now, our agent here, as we saw before, is doing the same thing of creating a client to begin with, authenticating as my local user, creating the agent itself in AI Foundry, and enabling the hosted web search tool, and then finally running the agent itself. Now, something really interesting when we use things like the hosted web search tool is we can see here that our agent ran and it invoked tools, and we can see that there are references. Let's rerun that one. Cool. Give that a go. But we don't actually see the tool being executed. This is because the tool itself is actually running inside of the AI Foundry agent service. This means that the hosted web search tool doesn't need to run on my local machine, but rather runs as part of the agent's thread or internal loop. Cool. It's then gone through and it's come back with a result saying, would you like me to find a list of recommended venues? Perfect. Absolutely happy with that. Let's move on because there is something a little bit more interesting here when we begin to introduce a few more agents. But before we build a multi-agent workflow, I actually wanted to dive a bit deeper into these tools because hosted web search tool is great. It's straight out of the box. But we may actually want to use not just a traditional web search, but MCPs, giving us the ability to plug in any tool, any MCP server that would like. Now, it's important to note here, when we begin to think about MCPs, there are a ton of different options out there. There's MCPs that can point to MS Learn and our online documentation. There are MCPs that can provide complete control over your local computer. So it's important to think when we look at MCPs, doing a little bit of due diligence. Here we're going to be looking at an MCP that does run on the local machine. So we'd want to do a scan of that to make sure that it doesn't have any vulnerabilities before we used it. But we can also use remote MCPs, and we'll talk about that in a moment. But let's actually add an MCP tool in and make our coordinator a little bit smarter. Because here so far we've looked at a venue planner, but coordinating event is a little bit more than just having a venue. So in Demo 3, we introduce our event coordinator specialist, whose job is to focus on actually putting together a plan. Here you'll notice it's exactly the same structure. We create our client, we create our agent, and then from there we can define the tools that we'd like to run. Here you can see that we're actually running an MCP standard IO tool, which means that it's running on my local machine and using standard input and output to talk between the MCP server process and my application. And you can see here that we're actually just using one of the Model Context Protocol MCP published MCP servers. In this case, this MCP is designed around creating to-do lists, actually building up context over time and then resolving that to-do list, if you will. I like to think of this as nearly a step before reasoning, if you will. It's providing us a list of things to do that we can then actually begin to reason through. Now, running this agent is exactly the same as the last one. The only difference is where the hosted web search tool lived in AI Foundry on the agent service, the MCP tool that we're using here lives on my local machine. So it's going to spin up a process and run it. And in the background, it's actually going to start communicating between my agent and the MCP server itself. Now, the important thing here is because that coordination is happening locally on my machine, it means that we're not just going to see a call off to the agent and then a response come back, but rather we're actually going to see a conversation and coordination between where this code is running and the agent itself. So the agent in AI Foundry will run, and then it will come back and say, hey, you need to call this MCP. In this case, we can see here it's doing its execute tool sequential thinking. That MCP then executes, returns a result that then goes back to the agent itself. So you actually end up in this world where we pass off to agent service to run. Agent service then passes back to the Microsoft Agent Framework to execute something on local compute, and then we pass the result back to the agent itself. If we give it another run here, we should actually see it come back with a few more sequential thinking events. One of the nice things about non-determinism and small prompts to make it nice and readable is that you end up having it maybe do one execution and find what it needs to, or may need to do multiple executions before it finds what it needs to. The other thing I'll note here is that it's not just MCP standard IO tools, so things that run on our local machine. We also have things like hosted MCP tools. And I should be able to just quickly import that. And you can see here that a hosted MCP tool, rather than necessarily pointing at something on my local machine, we point towards a URL that we actually can connect to and execute there. This is really interesting because now it's not the Microsoft Agent Framework sitting between the agent service and a local process, but rather it's sitting between a remote MCP server sitting at a URL and the agent service, and it can coordinate between those two. This to me is a more enterprise-ready way of doing MCP, setting them up as remote MCP servers, either over SSE or ideally HTTP with SSE. I will not get into that because it's a little bit more of a technical concept in terms of the differences and approaches of MCP. But it's important to note that the Microsoft Agent Framework actually supports both modes straight out of the box. So if you do have an existing MCP server that's local only, you can use that with the Microsoft Agent Framework. If you have a remote MCP server that you've built and put together or have created via something like Azure API Management, you can use that with MCP in turn. Perfect. So you can see here that rather than just running a single sequential thinking step, it actually went a little bit deeper in building out a plan. Here we can see that it's built out multiple steps. So venue, catering, entertaining, logistics. And it's 100% right. We need all these different areas to build out an event. We can't really just pick a venue and be done. So I think it's about time that we look at, hey, how do we begin to step beyond just looking at text and begin to structure our responses so we can begin to compose our agents together and plug them into each other. So the next topic we're going to be looking at is structured output. And when we begin to think about interacting with an LLM, one of the biggest things that changed about 1.5 years or 2 years ago was shifting from thinking of an LLM as just outputting text to instead being able to output something in a known format, in a schema, if you will. And kind of the cornerstone of a lot of modern agentic frameworks is the whole idea that rather than just accepting whatever the LLM comes back with, we can actually put structure around the response itself. Now, as I said a little bit earlier on, you could build this yourself from scratch. There's nothing stopping you building a prompt that says, hey, I expect a response that looks roughly like this and has these JSON properties. And when it comes back, you do the JSON.parse or XML.parse or whatever approach you want to take. But I find that if you spend all of your time focusing on the low-level parsing, you kind of miss the benefit of structured output, which is being able to focus on the model or the thing that's relevant to the business itself. So in the Microsoft Agent Framework, it takes a little bit more of a generic approach where we actually begin to specify, rather than just saying, hey, give me some text in and out, we can then actually begin to specify response formats. And here, our response format can point towards a model. Now, internally, this is using Pydantic. So if you've used that before, absolutely amazing, especially in terms of parsing and model generation. And in order to use it with the Microsoft Agent Framework, we just need to build a model that inherits from base model. and we can add any properties we want on here. The nice thing is when this is sent off to the Azure AI Agent Service or to an LLM, it will convert that into a structured output schema that will then be passed to the relevant LLM. So you don't have to sit there and think about, hey, what's the difference between structured output across chat completions versus responses API versus some of the slightly different APIs that are out there for LLMs. The framework actually takes care of it for you. You instead begin to think about the model itself. Now, I will throw in here the biggest caveat ever, in that just in the same way we can get input from a user that might fit a model but might not actually be valid, the exact same thing exists for large language models. We might be able to get a JSON payload back that looks exactly the right shape, but has completely incorrect data inside of it. So I'd highly recommend, as you're building up these systems, begin to think about how do we do model validation in the same way we would for users, but instead for LLM outputs. And we've seen the whole rise of prompt injection and being able to control the response that comes back. If you're using structured outputs and putting validation on top of it, that gives you a really nice safeguard around controlling what outputs should come back. If you're really only expecting a number between 1 and 100 to come back from the LLM, putting that in a structured output, doing parsing correctly, and then validating ranges really restricts what prompt injection could possibly do if it does get through things like content safety. Now, using these models is really nice because we can not just use primitive types, we can actually use things like lists and build more complex structures. We can do optional fields. The low-level implementation is just a JSON schema. So anything we can really define as that, we can do through these models. But I will say it all comes down to readability. If you're building structured outputs and you have a property called A, or a property called result, it doesn't really describe what should be in it. And the large language model will struggle to understand what should actually be placed into that property. I like to think of this as, well, the best models you can build are being ones that you can actually give to someone from the business, a stakeholder, and actually ask them, hey, could you fill out the values of this? If you can do that, then chances are you'll probably be able to, inside of a prompt, describe how that should be filled out to an LLM. But let's scroll down and actually execute this exact same approach again. And you'll see we're still using our web search, slightly different approach that we'll come back to a little bit later on. But we're building our agent, we're passing in our tool, we're running our agent, but we're then saying, hey, I want this as a structured output rather than just text back. But there is one big gotcha that a lot of people miss, especially if they're just used to using the LLM libraries directly. The agent framework actually gives you the ability to be specific. Should it come back with a particular format, or is it optional? And response format by default actually gives the ability to come back with either a value, which is our structured response, or text. So if it couldn't fill that out, or if we say, hey, instead of responding with a structured output, respond with a question that I should ask the user, you can actually begin to guide and control the conversation. I find this is really, really handy, especially if you have models that aren't necessarily trained on structured outputs, or to a degree, you find that the non-deterministic nature gives you less than expected results. Having the ability to pick up both text as well as structured output is really nice. As I said, you can also lock it down to say, hey, if it doesn't fit this format, just completely fail and throw everything away. But actually being able to understand what's in the structured data or what's in the non-structured data if it does come back is really helpful. Now, inside of here, I will call out that we can go through and actually look at our individual items. So I can see here, well, actually, if I scroll up to the top, because we missed something important, we had our agent and our tool do a web search. It went off, found the most relevant venues, but rather than coming back with that text that we saw before, we actually get back that structured output. So we've got our title, address, description, services that are offered, cost per person. Ideally, I'd actually probably have services as an enum or an array of well-known values. Like, there are a whole lot of options you can do here. But the most important thing is that we've been able to go from just text coming back that could be in any format to instead being in a structured format. The most important thing is we've done it by just defining our models and setting that as the response format. So super impactful and super powerful, but more importantly, when we begin to compose these agents, we can now restrict what they come back with and begin to control how we move from agent to agent. But all this talk about agent to agent, how do we actually build a multi-agent system? You've seen at the top that we can create a client and then create an agent, but how do we actually compose them? And there's two different ways to do this. We'll start with workflows, because ideally this is what we should be looking to use for large-scale multi-agent systems. But we can also have a slightly different approach of a tool call-based agent invocation, which we'll talk about a little bit later on. So in Microsoft Agent Framework, when we want to begin to build a workflow, we actually start by adding and registering our agents. So let's actually close these off and jump across to our next demo. Here we go. Perfect. All right. Rather than necessarily creating one agent, we can actually create a workflow and register agents to that workflow. And this is something that is slightly different in especially recent releases of the Microsoft Agent Framework versus previous releases. This register agent is actually taking in a Lambda or a delegate to create an agent. This means that the workflow is now responsible for actually instantiating agents as required. So we're not necessarily creating the agents up front anymore, rather that we're providing methods to create these agents. And you can see here we can pass in our register agent, so what we'd actually like to create, and then give it a name. So give it a name within the workflow itself. I find this is really handy because it now doesn't matter what our agent actually is, whether it's built on top of OpenAI Responses API, whether it's built on top of AI Foundry's agent service. This gives you the ability to just name an agent. And especially when we look at A2A a little bit down the track, having the ability to just refer to an agent by its name is really powerful. But having the ability to register our agents is kind of our first step. We actually then need to define how these agents will be related to each other. And this is where we begin to move into a workflow engine. We can begin to actually define steps and processes. So here I've got a very straightforward example of a sequential execution where I start at the coordinator and then go from the coordinator to each of the individual agents before I then end up with my booking agent who finalizes the plan. We can very much think about this as agent 1 will run until it gets to its result, and then agent 2, and then agent 3, and then agent 4. But the nice thing about registering our agents is we can actually begin to go above and beyond that. Now, it's beyond today, but I highly recommend that you have a bit of a play with this yourself. Inside of here, we can not only add edges, but we can add in chains, so sequential chains. We can add fan in and fan out, giving you the ability to have one agent trigger multiple agents, and then multiple agents fan back in to a single agent. We can begin to do switch case selection. So based on a result of a previous agent, what should be the next agent that's picked? And this is really, really powerful because it gives us the ability to build a workflow of agents without actually touching the agents themselves. You notice here we've just registered and built our workflow. Now, there are some requirements around this in terms of how we pass information from agent to agent. If we're doing a fan in, for example, that will be a lot of agent information actually coming back into one place. So there are some restrictions on the agents that you add in. But if we're doing sequential or basic chains, we can really just pass from agent to agent. The other thing you'll note up here is that I've set output response. This means that this is the actual bit of output that we care about. And this is really interesting, and it's the big pitfall that a lot of people run into when they first use workflows. Workflows can be paused and stopped at any point in time. You can use tools to interrupt them. You can use workflow state to interrupt them. But sometimes you really just want a terminal state, a final agent that, when executed, gives you output. And output response is one of those flags that says, hey, for this agent, when you reach this agent, we should be thinking about this as an output stage. And you can attach this to multiple different agents if you want to fan out and then terminate. But I find that this is a step that a lot of people miss when they begin to actually build more complex workflows. But let's actually execute. Let's clear this out and let's execute our workflow and talk about one other thing that's in here. So the workflow builder is responsible for actually building up our graph, our agents, constructing all the different edges between them or chains or fans. But we actually need to then pass this to an execution. Now, this, funnily enough, works the same way as an agent. And for those that are wondering, yes, you can actually take a workflow and treat it like an agent. You can have workflows of workflows. You can wrap a workflow in A2A. The whole idea here is that whether it's an agent that's being run or a workflow that's being run, you have that same sort of process. Now, for everything that's running here, this is all running in memory, but there are options to actually externalize state within the Microsoft Agent Framework. So if we wanted to scale this out across multiple servers, we could spin up a Redis cluster and actually point it towards that. The other thing you'll note down the bottom here is that we see all of our individual items. So here we're doing our sequential thinking, and then our event coordinator is now running through. We've now executed our venue specialist. What you're seeing here is actually a trimmed down version of the logs that are generated. You've probably noticed at the top that we're actually using OpenTelemetry for all of this. So you can see here we're using OTel providers. In this case, I'm just using the console output trimmed down. This means that you can observe this on your local machine using local OTel tooling, using the console, or even using things like application insights. And I find that's really important of having a common observability pattern, both on your local machine, as well as when it's published into an environment. Awesome. So if we scroll back up here, we can see that we've gone from these different agents. We've invoked these different agents in a workflow. We can see that we've done web searches in between. We're running tools. We've called external services. At the top here, we had our sequential thinking. So I've actually gone through and built out both our plan, which is what our coordinator did via the MCP server. We've then looked up different venues and catering options via web search, and then combined it all together using our booking engine to actually build, there we go, our venue offering. Does this align? Are there any dietary restrictions? Perfect. We're all up and running. Now, it's important to note here that this code is actually really simple to understand when we look at it from this perspective of saying, hey, I've got some agents and some edges. But you're probably thinking that when we get to more advanced workflows, this is going to be a complete nightmare. What if we have dynamic workflows or workflows that are built up with multiple different pathways or fan in and fan out or workflows that continually loop? You actually end up with a pretty big graph. So rather than just looking at it as code, the Microsoft Agent Framework also has the Dev UI that allows us to take it one step further and visualize our workflow. So let's jump across here. And I'll just quickly put up the slide so we're going to marker. So visualizing with Dev UI gives us the ability to take the same workflow that we were looking at a second ago. So if we look here at our workflow builder, it's exactly the same. We're registering our agents, we're adding our executor, we're adding our edges, we've got our output response. But rather than running it, we can instead serve it using the Dev UI. Now, this means that if you've built up your workflow within a method, you can either choose to then run that workflow, which is your execution path, or serve it via Dev UI. This to me is the composability of the Microsoft Agent Framework. The ability to say, hey, it doesn't matter whether we're publishing or whether we're debugging, we have the same sort of flow. And you can see here inside of the Microsoft Agent Framework, and let me zoom this in, we can actually see a graph of all of the different steps we had. We've got our event coordinator, our venue specialist, our catering specialist, our budget analyst, and our event booking specialist. And we can see here that all of these sit in a sequential workflow. And that's our event planning workflow. But we can actually dive one level deeper and look at the agents themselves. I can jump in and say, for example, have a look at let's look at our venue specialist and open this up and get a small card representing this agent. I can see that it's running in memory, and we'll talk about that in a moment. I can see the instructions that it's provided. I can see that it's being given a web search tool. So we can actually begin to visualize what our agents are in a nice little card format. Likewise, when we actually go to our workflow, it's not just about visualizing, we can actually begin to execute. So in the same way I could do .run previously, I can actually just click configure and run, specify my input, in this case is it's a chat message, and it will begin to actually execute each of these agents one by one in the workflow that was defined. To me, this is super powerful because it means you can codify workflows and describe them in very simple terms, but then debug and diagnose in a visual manner. The nice thing here is if I wanted to, I could actually put a breakpoint on any of the tool calls or anything that's happening inside of my Python library and jump between this visual flow and that code first flow. And we can see here, if we jump across to our tools view, we can see individual tool calls. So here's our sequential thinking. We should hopefully have some web searches popping through in a minute. Oh, that's all right. We'll let it just run and do its thing. This gives us a way to visualize what actually happened for a given execution, which is really, really nice. I will also call out here that behind the scenes, because it is just running locally here, I can actually jump in and see all the logs that I saw before. Here we're just seeing our Azure AI agent client complain because I don't have any persistent storage. So when I stop this, we're actually going to drop the thread, but that's okay. So if you're beginning to use the Microsoft Agent Framework, having this workflow is super, super important. But let's jump forward one step, because everything that we've seen here, if we begin to look into these agents, so I'll go to my Create Coordinator agent, you can see that it's just doing the same agent client create agent with some instructions and some tools. And this is great if I have all of my agents locally, if I'm happy with them all running inside of the Microsoft Agent Framework. But what happens if we want to do true A2A, where an agent may exist on an outside system or somewhere else? Well, luckily the Microsoft Agent Framework has A2A baked in as a first-party principle. And in fact, it has two core components. It has the ability to act as an A2A client using model cards to actually discover other agents and invoke them, as well as act as an A2A server. And just for demonstration purposes, we can have a look at what it looks like to actually build an A2A system. The biggest difference here is, rather than instantiating a Azure AI client or an OpenAI chat client or similar, we instead use an A2A card resolver to retrieve a remote agent. And then we can use that agent to build an A2A agent. Now, if you remember back at the very beginning, I said that when we begin to talk about these agents, they are generic. It turns out that the same base class that's used across all of these agents gives us the ability to do .run. So the agent.run here, it actually doesn't matter that this is an A2A agent. This .run will begin execution and kick off. Now, we can actually kick this off and run this and see it actually interact with our remote A2A server. Let's close down that one and restart this one. Perfect. The important thing to note here is that because A2A is looking at something remote, I've got this running on another process, and we'll look at the code for that in a moment. The other important thing to note here is that we need the agent host to discover the A2A agent card. In this case, it's found the agent, which is policy agent. We can then execute against that agent, run, and get the response back. So from the Microsoft Agent Framework perspective, this A2A agent is just another agent that can be orchestrated. It can be added to workflows, it can be called, it can be wrapped in tools, it can be part of a larger workflow. And that's really, it gives you the ability to be incredibly flexible when it comes to orchestrating. I will also say that you can take an existing system and give it an A2A interface. Behind the scenes here, and we're happy to share the code of this once we're done with today, is just a .NET application that defines, and funnily enough, this is using the Microsoft Agent Framework. We've got a .NET project that builds an AI project client, that builds an AI agent, and from there builds an agent card to be sent across the wire to any A2A clients that are requesting it. The important thing to note here is that A2A is actually a pretty big spec. I mentioned before the whole idea of long-running events and things that might take days or weeks rather than seconds to execute. So things like push notifications for A2A give us the ability to do that. But just be aware, if you're opting in and saying that your agent can do that, you need to make sure that you actually implement that behavior. The Microsoft Agent Framework helps you with all of those building blocks, but you just need to be aware that if something's expecting to run for multiple days, we need to be thinking about how we actually host it. All right. The last thing I wanted to mention, and we'd actually jump back to the dev UI for this. Let's jump across to here and launch this up again, is that the Microsoft Agent Framework isn't just around building agents and composing agents as part of workflows. It actually has opinionated methods when it comes to session and memory, and also the ability to deploy. So you'll note here inside the dev UI, there's actually a button down the bottom right-hand corner called Deployment Guide. And if we open this up, it'll give you a best practices approach to how we begin to actually wrap this agent together and deploy it. You'll note down here that when we look at things like the requirements.txt, it's only including the core framework components rather than absolutely everything. So just the pieces that we need. My favorite part though is if we scroll down the bottom here, it will list any production considerations that exist for this current project. So I mentioned before that it's all in memory. So if this thing restarts halfway through, it will lose context. It will just stop. There's no authentication or security because I am just running this locally on my machine. And Dev UI will actually give you warnings about that as you're developing. So I find this really, really handy to actually look at what is happening inside of your project if you're using Dev UI. But let's move on to our last topic before we open up to some Q&A. And this is a little bit more of a fun one because I wanted something to end with that everyone could go away and have a bit of a play with. And it turns out that we can actually begin to use software engineer agents or GitHub Copilot or that whole idea of agentic development to build agents. So we're not just necessarily designing agents to be used directly, but we can design agents to build agents. And my favorite way to do this is actually using agent files, or agent files is the best way to put it. So if we have a look up here, I've got an agent file, basically a markdown file that describes how I build agents. And it's nice because if you begin to read through this, it actually reads like a prompt, because at the end of the day, it is just a prompt, but it's really focused around one particular task. And if you've worked with code generation tools before, you'll probably find that you give it a task, but you're not specific enough, and it ends up going down a completely different path. What I find is with agent files, so .agent.md files on top of GitHub Copilot, you can be very specific around the way you want to design code, around the libraries that you want to use. And in fact, in my agent.md, I've not only given it instructions of what to do when creating a new agent, but also templates to fill in. So I'm just going to open up GitHub Copilot here. And rather than just using straight agent mode, I'm going to switch across to my agent creator, which is the agent definition I have here. And I can say, create a, what's a good one? Create a decoration agent. Let's run for that. And what it's going to do is look at that particular agent file, taking in that context to then implement the agent following our best practices that we've defined. This to me is how we can be incredibly efficient when it comes to using agents to build software, because we're not just letting it go off in any direction, we're being specific around the types of frameworks and libraries and approach it should use. And you can see here that it started to build out another agent in our agent file. It's beginning to construct its instructions. It's given it correct naming. It's built out the method correctly. It's using the Azure CLI credential because that's something that is defined in our agent file. So if you are starting to build out things on top of the Microsoft Agent Framework, using tools like GitHub Copilot to help build in a very specific manner can be incredibly powerful. I also like to reflect this around the other way and say, if you as an organization want to look at code-first agents, be considerate of actually building agents that review those agents, that actually go in and check for things like, hey, is security a concern here? What authentication and identity is being used? Is this something that runs locally or retrieves resources sitting on a public NPM server? Or is this something that runs entirely within a sandbox? You can begin to codify and build up those agent files to help you review the code first agents that you build. Now, I will say here that it isn't just as good as saying, hey, build me a decoration agent that integrates with XYZ. It's probably not going to get it perfect the first time. But because we have the ability to use the Microsoft Agent Framework to debug and diagnose locally, to run, to execute, to put in breakpoints, and then productionize when we're ready, it gives us a really simple approach to building agent-to-agent systems at scale. Now, with that, I'd like to do a couple of quick wrap-ups before we see if there are any questions and any feedback. So first and foremost, a QR code. If you've enjoyed today's session, if you've got feedback, if there's something you'd like more information about and want to dive deeper into, I encourage you, leave your feedback. It's important for us to know what topics excite you. Did you want to go deeper on a particular area, or was this too low level? Please let us know what you've thought of today's session. Highly recommend giving us feedback. QR codes on screen. We can always come back to it. The second one I'll call out is that this isn't actually the first session, and not even the first session for this year. This is actually session number 2. I highly recommend going back and revisiting session number 1, which looked into some of the agentic AI in Foundry fundamentals of how to build and evaluate agents in Foundry itself. I found that it's incredibly important to understand how we build agents in low code or Foundry-like environments, as well as in pro code, giving us the ability to compare between. There's also a back catalog of previous seasons that you can go through, and I highly recommend, if you're looking for more content like this, to check out the back catalog. Lucky last is we do have an AI Genius certified badge. So there is a QR code here that you can scan to display on your social to show that you've gone through, you've watched and taken something away from today. I really hope that this has been helpful in terms of understanding what the Microsoft Agent Framework is, what agentic behavior is, full stop, but then also how we can begin to compose it together. And it's funny because I gave a very similar presentation 2 or 3 years ago when we were first beginning to think about the whole idea of multi-agent systems. And to display that same workflow that we built up in 10 lines of code was 150, 200 lines plus a complete custom engine off to the side. It's really amazing how far these frameworks have come, giving us low-level fundamental building blocks that are actually incredibly powerful. With that, I'd like to say thank you so much for attending today. If there are any questions, please feel free to drop them into the chat or the comments, and happy to address them as we go. All right, let's have a quick look at chat. And wow, it has been a busy chat today, which is absolutely fantastic. Have there been any standout questions for today? Let's have a quick look. Hello. Awesome. Yes, we've got a bunch of links at the end. Thank you. This is a good one to remember. We will also share a link for a lab. If you'd like to actually run through today's content and look at it step by step and actually understand how you implement each of those steps, we do have a lab that will take you through it step by step. All of the content, all the code samples you've seen here are all based off that lab. A lot of them have been simplified to show on screen, but the lab takes you into a little bit more detail of how you build it into an overall production-ready system. Perfect. Awesome call out by Michelle there in terms of the fact that the Microsoft Agent Framework isn't just autogen and it isn't just semantic kernel. It is a higher level abstraction that is extensible by default. And what you'll find is that a lot of the things that were tricky to do in SK and autogen are actually first-party concepts within Microsoft Agent Framework. My classic example here is the whole idea of actually building custom agent execution modes. In autogen, you could do it, but it was quite complex. In Microsoft Agent Framework, we have those base classes there that you can inherit from and just override methods, giving you the ability to actually change behavior without having to build out brand new executors from scratch. So it is a really powerful higher level framework. Awesome. I had a question here around an orchestrator agent that actually builds workflow steps and things that should be done in order. Like, this is what we tend to look at around non-deterministic workflows. The biggest thing here is we actually still build a workflow, but rather than necessarily having a predefined workload, we build switch cases. So an orchestration engine would run. It would then come back with a structured format that says this is the next agent to run. You can then use switch group or switch case to actually then select which agent should then execute and then return back to the coordinator. So the coordinator can be building out a sequential list of steps, but you then dynamically select which agent is next. I often find that if you have an incredibly complex space, non-deterministic workflows are an incredibly powerful tool. But I will say, if you do have a simple workflow that's fairly well known, leaving that up to a non-deterministic LLM can be a little bit of a risk. I like to have fixed workflows where steps are really well known, and then use the switch case and actually saying this agent should be invoked or this agent should be invoked for times when we need to have that non-deterministic execution. Great question. Difference between add edge and add chain. Add chain is really wrapping it up in terms of, hey, here is an array of steps that it runs through. Add edge is more generic in terms of an edge might exist pre or before a fan, for example. So we might have an edge transition from one agent to another that then goes from there to a fan out, from there to a fan in, and then from there to an edge. You can kind of think of add edge as being the most generic base case. Perfect. All right. The registered agents are created and deployed in exactly the same way as the original demos. Yes, you're absolutely spot on. So each of those agents, and I can actually jump back to the code for this for a second. Each of the agents we have that are created here build their own client and then create the agent from there. One of the biggest things I find, especially around the Azure AI Agent client or Azure AI Project client, is that you will need a client per agent because of the way the Azure AI Agent client links the agent name to the connection. So I highly recommend, if you are using the agent service or Foundry agents, instantiating a client as part of your agent creation, keeping that as a one-to-one relationship. One thing that I'm not showing here that I've cut out for brevity's sake is ideally we should be using even something as simple as dependency injection to actually manage the life cycles of each of these components. Your agent client and your actual agent itself both have exits and actually have control protocols. So realistically, we should actually be disposing of them, disposing of them. We're not doing that here, but in a production system, I'd highly recommend, just so you don't have them floating around in the background. Perfect. Awesome. Handoff orchestration for A2A. This is a really interesting one. At the end of the day, A2A is really just a step in a workflow. Handoff orchestration can be seen as an edge. It really comes down to, are you expecting it to return back? One of the biggest things I see with A2A is just having one agent with a tool that calls another agent. You end up having non-deterministic execution of the second agent, which could be a behavior you're absolutely looking for. But I tend to find when you're building systems and workflows, especially using A2A, you know when an A2A agent should be called. More importantly, if you are using workflows, you can begin to then wrap A2A agents and restructure the output if you need to, or summarize the output. And rather than having to write a complete custom agent, you can actually just have a workflow that is call the A2A agent, and then step number 2 is take the output and create structured output from it. So I tend to find the workflow is a lot more flexible in terms of breaking down tasks in systems that use A2A, but by all means, you can just do complete handoff. Yes, and all the sample code here we will share as well, including the agent file if you'd like to play around with it. Awesome. Great question around integrating with other systems like Copilot Studio. Basically, anything that uses or exposes an A2A endpoint, Microsoft Agent Framework can call. For Copilot specifically, there are different approaches in terms of invoking Copilot Studio or having Copilot Studio invoke the Microsoft Agent Framework. I'll point you towards our documentation for the latest on that one. But fantastic question in terms of combining both pro code and low code together. And I'll drop a link for that in at the moment. But I think with that set of fantastic questions, thank you so much for your time. We're coming up to an hour 15, so hopefully this has been really useful. By all means, please feel free to play around with these technologies. As I say, pro code agents can be so powerful and can solve incredibly complex problems. But when we begin to combine it with something like Microsoft Agent Framework, where we have workflows as first-class citizens and the whole idea of being able to structure agent-to-agent systems in a very straightforward manner, all of a sudden the complex actually just becomes that little bit simpler. But with that, thank you so much for your time and have a great rest of the day.